In this video, we'll be calculating the current flow through a filament from a steady movement of a certain amount of charge in a given amount of time. So in part A, let's draw a filament. It has electrons moving. The charge of these electrons is given, and so is the amount of time. Charge denoted by Q is 75 coulombs, and the time it takes is 5 seconds. To calculate current, we divide charge over the given amount of time, which is 75 coulombs over 5 seconds. That's 15 coulombs per second, which is also 15 ampere. That means 1 ampere is 1 coulomb over 1 second. Part B is 30 coulombs in 3 minutes. As stated in the previous problem, ampere is calculated as 1 coulomb per 1 second, so we have to change the minutes or the unit of time into seconds, which is 3 times 60 seconds, because there is 60 seconds in 1 minute. That's 180 seconds. So current can be calculated as 30 coulombs, which is the given charge in our part B of the question, divided by 180 seconds. That's 0.1667 ampere. For our part C, we don't have the amount of charges, but we have the number of electrons flowing through and the time, which is given in hours. So let's change hours to seconds first. 1 hour is 60 minutes, and there is 60 seconds in a minute. That means 60 times 60 seconds, which is 3,600 seconds. Therefore, 1.5 hours, or 1.5 hour, is 1.5 times 3,600 seconds, which is 5,400. This is our time. One electron, the charge of 1 electron is given as negative 1.6 times 10 to the power negative 19 coulombs. Therefore, charge of 3 times 10 to the power 21 electrons is given as charge of 1 electron, which is negative 1.6 times 10 to the power negative 19 coulombs, times the number of electrons we have, which is 3 times 10 to the power 21 electrons. That's 480 coulombs, and that is the charge. There should be a negative. It's negative 480 coulombs. The current that is to be calculated is Q over delta T, which is negative 480 coulombs divided by 5,400 seconds. That is negative 0.0889 amperes. That's all I've got.